Hey guys, sorry I couldn't be at school today. I'm like half dying, I think. But anyway, I hope this recording helps if you need some clarification on it. So I'm going to start with number 1 and then we'll just keep going from there. Okay, so rewrite the following in exponential logarithmic form. So to do that, we always take the base of the log and then we put it underneath the other side, because what log says, it says, what power do I need to raise 3 to in order to get 1 over 9? And so 3 to the negative 2 equals 1 over 9. And so this right here should be a true statement. If it's true, then you've rewritten the exponential form correctly. Okay? So another example of that. So now let's go backwards in part B here. So the base of the exponent always needs to match the base of the log. So we're going to write log base 4. And then it always goes, whatever's on the opposite side is the thing that goes next to the log. So log base 4 of 13, and then it equals x minus 3. So these two things kind of switch places. So this would go to this side, and then this would go to this side. All right, same idea for C. So if you guys needed that, I'll let you try C on your own. Okay, next we're going to evaluate the following logs. So again, this is going to be equal to some number we don't know. So 4 raised to what power is going to give us 2. And so then this is a in our head problem, right? So if we take the square root of 4, we should get 2. And we can remember that 1/2 is the equivalent to square root if it's an exponent. All right, so B, again, we say, well, what power can we raise this to get 1/3? And so we're going to take 3 to the x equals 1/3. Then x is going to be negative 1 because we want it to flip. Okay. All right. Let's take a look at C and E. So C right here, this is a log base 2 of 8 to the 3x. Well, how can we make this base 2 cancel with something that comes from 8, right? So we want to do a little change to 8, rewrite it in a different form. 2 to the 3rd power is how we could write 8 also. Okay, so then 3 times 3 here is going to give us log base 2 of 2 to the 9x, right? Whoops, sorry. 2 to the 9x, and then we can drop that down to the front. 9x log base 2 of 2. Now this and that become 1, so then we just get 9x. Okay, natural log. Let you guys do that one. Okay, so here we have a power of log base 3, and then the base of that is 3. So that's good because these two things are equal to each other. We can say they cancel, and then what would be left with is 2x minus 1. Okay. All right, so let's continue. Finding the inverse. It should hopefully be a little bit easier now that we've done some solving questions. So find inverse, we always flip x and y first, like this. Okay, so it's going to be x equals the log base 5 of y, right? And so we learned with solving that we can exponentiate this log to have a base 5, and we would have to do the same thing here. So then we're going to have 5 raised to the x equals 5 to the log base 5 of y, right? These two things cancel, and then we're just left with 5 to the x equals y. Awesome. I'll let you guys try natural log out. Okay, graphing. I'm going to skip 4, I'm going to go to 5, because 5 is definitely the harder graphing problem. it's natural log, and there's an a value. Okay, so always want to decide, well, what's the parent function here? So ln of x. So we have the ln of x equals y. Another way to rewrite that, right, is base e. So it would be e to the y equals x. Rewrite it in exponential form. Build our xy table. And we always pick the same 3y points. So 1, 0, -1. E to the first power is going to be 2.72. E to the 0 is going to be 1. E to the -1 is going to be approximately 1/3. Not quite. Okay. So those are the first couple points we could graph. So we're going to go 1, 2.7. At 0, or at 1, we go, whoops, sorry, that's up 1 right there. 1, 2.7, up 1. We're going to go 1, 0, and then we'll go -1, 1/3, right? And so now we can come back over here and we can see this tells us, whoops, need to look at this right here first. Remember, multiplication comes before addition and subtraction. So this tells us multiply all y values by 2. Multiply all y values by 2. So times 2 times 2 times 2. Oops, -2. Definitely -2, guys. Sorry about that. Okay, so then we have 2.72, comma, -2. We have 1, comma, 0. And we have 1/3 approximately, comma, 2. So then these are the new points we can graph. So we're going to go 2.72 down 2. 1, 0 stays the same. And then up to 1/3. Okay. And now we can do our shifts. So I'll make those in green. This tells me left 1 and then up 1. So left and up. Okay. So then I'm going to go here. I'm going to take all of these points, go to the left 1, up 1, left 1, up 1, left 1, up 1, right? I always need to draw in my vertical asymptote right here. So that's going to be x equals -1, comes from our shift. So then we just connect the dots. Bada bing, bada boom, and we have a graph. All right, let's talk about the domain and range. The domain is going to have to do with our shift because this is what are my x values. So it's going to be from -1 to infinity. It's never going to hit -1 because that's asymptote, but it's going to almost make it. Our range is always going to be all real numbers with the log or natural log. And then our asymptote equation, I already wrote it, is x equals -1. Sorry about that. Okay. Next, we're going to expand the following expressions using properties of logarithms. Okay. So I'm going to let you guys try this one on your own. Let's go over to the one that's a little bit harder. Okay. So we always want to split up everything. So these things are going to split. This is going to split. So we're going to have log base 6 of x, log base 6 of y squared, and we're going to have a log base 6 of z, and then I'm going to change that to the 1/2 because I like having powers. And so x and y are multiplied, so that's plus. Z is divided, so that's minus. Like I said, if you like these parentheses, you can definitely have them. But if you don't like them, you don't need them because it's just one thing in the bottom. So if we would reverse this, I'm going to write the reverse up here. It would be log base 6 of x times y squared. and then that would be minus the log base 6 of z to the 1/2, okay? So it's okay to not have parentheses there, because as we read from left to right, the multiplication is going to be done first. Anyway, let's continue this. So no exponent on the first one, exponent on the second one needs drop down, and on the third one needs drop down. So we have log base 6 of x plus 2 log base 6 of y minus 1/2 log base 6 of z. Alright, and then that is our final answer. Okay. Cool. If you're still here, it's probably because you have to wait for some questions on the bottom. You could probably fast forward a little bit, because I'm only on, page 2 of 3? Yeah, but we're almost there. Okay. Condense the following expression using the properties of logs. Which one should we do? They're both pretty similar. Let's do this one. So we always want to condense it so that it's just the log of something. So my first move is going to be this. So I'm going to have log base 10 of 3 plus log of x to the 1/2 minus log of 5. Okay, now going forward, plus tells me multiplication, so log base 10 of 3 times x to the 1/2 minus log of 5. And so then my final answer is going to be log 3 x to the 1/2. Whoops. Let me move this, because we need divided by 5 in there. Okay, and by all means, if you only show one step, I totally understand that. Just show me that you know that this goes here, and then if you want to combine all of this in one step, go ahead. Feel free to. Just got to be careful that it's just the 5 in the denominator and nothing else. Alright. Same with this one. The only thing that's going to be in the denominator should be this 3, okay? The difference would be if there was a parentheses here, then the ln of 3 times 6 would be in the bottom, and then the x squared would be in the top, okay? But only if there was a parentheses there. Because there's not a parentheses, only this 3 should be in the bottom. Okay. Let's do one of these. That's a good one to do. These ones are all pretty straightforward. I'll just do this first one. Okay. Log base b of 10. So we need to decide, well, we have 2 and 5. So we need to see how 2 and 5 go in there. Log base b of 2 times 5. So then we can split that into log base b of 2 plus log base b of 5. Then we know what those values are. 0.5646 plus 0.7124. Add those together and it's a number. I'll do that. No, I'll just do it on my calculator right here. Hold on. 0.5646 plus 0.7124. So 1.277. Boom. Okay, so same idea here. Just use your properties of logs for both of these as you're going forward. Okay. Last page, solving exponential equations. I'll make sure to do all of these because we just started this. Okay. So let's do this one. Log base 7, because that's what's going to cancel out everything here. So if we take log base 7 of both sides, okay, so this and this cancel, we're just left with x equals the log base 7 of 32. Okay, so that would be considered the exact answer, but I always want you to go and give me the approximation values. So to do that on your calculator, it'd be log of 32 divided by log of 7. Someone yesterday told me that you can actually type this into your calculator. So if you have figured out that function, feel free to do that. I'm okay with that. Round decimals to 3 spots. Round decimals to 3 spots. Oh gosh, I wish I had my calculator. I was just using my phone calculator. Okay, so this next one. Okay, so this one's nice. We have 4 and 8, so we can do a change of base here. So 2 squared. X plus 1 equals 2 to the third. 2x minus 1. So then we get 2x plus 2 equals 6x minus 3, because we can just distribute that, okay? And then because the bases are the same, they can just go away because of the property we learned yesterday. So then just doing this through, subtract 2x, add 3. So then we get 5 equals 4x, and then so x equals 4/5. Boom. Alright. So remember when we're doing these, we always have to isolate the exponent. Okay, so we have to subtract the 1, negative 2 e to the 3x equals negative 14. Divide by negative 2, we're going to get e to the 3x equals 7. Okay, and now we can take the natural log of both sides. So we have natural log of e to the 3x equals natural log of 7. So then boom, boom. That's why I picked natural log, because it cancels. So 3x equals the natural log of 7. Divide by 3. X equals the ln of 7 over 3. And then again, get the approximation number. Okay, I want to see this number with the decimals in there on the quiz. Okay, solving logarithmic equations. So to start this one, what I would do is, because we're base 5, exponentiate both sides with the base of 5. Okay, so then this is going to cancel. We're going to be left with 3x minus 7. Then on this side, 5 squared is 25. Add 7 to both sides. 3x equals, what is that, 5 plus 7, 32. Divide by 3. So x equals 32 over 3. Done. Next one. This is one where we need to use properties first, because when we're solving logarithmic equations, we need one log to start with. So we're going to go log base 2 of x times x plus 6 equals 4. Okay, so then log base 2 of x squared plus 6x equals 4. And then now we can do our exponentiation. 2 on both sides. X squared plus 6x. 2 times 2 is 4 times 2 is 8 times 2 is 16. So x squared plus 6x minus 16 equals 0. Oops, and I forgot to check my answer for this one, but it works. So let's go log base 5. 3 times 32 over 3 is going to be 32 minus 7 equals 2. So that's going to be log base 5 of 25 equals 2. Good. Okay. Sorry, I got so sidetracked right there. Continuing this problem. X plus 8, x minus 2, factoring equals 0. So we get x equals 2 and x equals negative 8. Let's see if they're going to work. So if we look at it right away, negative 8 is definitely not going to work because we can't plug negatives into log. So if we did 2, it would be a 2 here, it would be an 8 here. So that would be 1 plus 3 equals 4. Boom. Good. Okay, last one, natural log. Isolate the logarithm. Natural log of x equals 2. E both sides. And we get x equals e squared. Okay, I kind of like e squared as an answer, but let's just keep going further. Whatever e squared is, what is that? 2.7. 2 times 2.72 approximately. I don't even know what that is. Okay. 2.718 times 2.718 is going to be 7.386 approximately. If you get a little bit different number, that's fine. I just rounded e to 3 decimal spots. Okay, so if you have more questions about this, guys, I will definitely answer them before the quiz tomorrow. If you're struggling with any specific type of question, go back and try to do that homework. The questions on the quiz are going to be really similar. These solving ones are going to be really similar, okay? So know how to do these couple solving ones. If you struggled, try to change the numbers. So say like number 1 right here, maybe change 7 to an 8. Change 32 to 40, okay? Just try different numbers with it. So 8x equals 40. Try to solve that problem. You can always check your answer because once you get a number for x equals something, you just plug it back in. When you plug it back in, it should equal 40. Okay? So you can always check your answers with these types of questions. So do that on the quiz tomorrow. Anyway, I hope this was helpful, and I'll hopefully see you tomorrow. I'm so sorry I couldn't come in today, guys. I literally feel so crappy. Anyway, yeah, have a good evening if you're watching this at night. If you're watching it during the school day, have a good rest of your day.